Hello, my name is Sam, and this recording is part of the molecular model project for Dr. Burns' chemistry class at Pellissippi State in the spring semester of 2023. So my group had the ability to look at this molecule called 4-methoxy-3-aminophenol. And their subscripts for each of the elements would be C7H9N1O2. So 4-methoxy-3-aminophenol is actually a naturally occurring substance with a six-membered ring comprised of carbons and then some branching out hydrogens, oxygens, and nitrogen. So looking at this compound, this molecule, we can see that all of the carbon atoms within this molecule have a trigonal planar electronic shape, which is going to mean that there's three fields of electrons within any given carbon atom within this molecule. The molecular shape of these carbons is also going to be trigonal planar because all of the electron fields are all bonds and not going to be any lone pairs. The bond angles are 120 degrees and the orbital hybridization is going to be sp2 because only two of the p orbitals have been filled at this point. So for all of the oxygens within this molecule, they're going to have an electronic shape that's going to be a tetrahedral. And the molecular shape of these oxygens is only going to be linear. This is going to be because although there are 4 electron fields around the oxygen, 2 of those are only comprised of bonds, and then the other 2 are going to be lone pairs. The bond angles include 109.5 degrees, and then the orbital hybridization is going to be sp3. At this point, all 3 of the p orbitals have been filled along with the s orbital. So looking at the nitrogens within this molecule, we see that they are also tetrahedral and their electronic shape, while their molecular shape is going to be a trigonal pyramid. Now this is because three of the 4 electron fields are going to be bonded, and then the last 2 electrons to complete the octet are going to be unbonded. They're going to be just a lone pair. The bond angles, similar to the oxygen, are going to be 109.5 for each of the nitrogens. And the orbital hybridization for all of the nitrogens is going to be sp3 because all of the p orbitals are full. Now looking at the total molecule itself, 4-methoxy-3-aminophenol, we can see that there are 19 sigma bonds within the entire molecule and 3 pi bonds in our molecule. Now all of the bonds are going to be sigma bonds, and the double bonds are what is included as the pi bonds. And since there are only 3 double bonds, those are going to be on the carbons where we're looking. So something that I actually found very interesting about this molecule is that its partner that was also on our assignment sheet, which is M-aminophenol, is more commonly used for hair dye, and I thought that was interesting because it can also be harmful to the skin. And for 4-methoxy-3-aminophenol, this is actually derived from a plant called Solanum nigrum, and it's used for a variety of different things, 2 of which, similar to the M-aminophenol, are hair dye, and then separately, it can also be used for a high refractive index film that can be transparent or heat resistant. And after doing a little bit of research, I found out that this is actually an example would be treated glass or a polymer. So yeah, thank you very much for watching. And all right, so this is a continuation of the previous video talking about the molecule that was given to us from the class which would be 4-methoxy-3-aminophenol. So scrolling up, looking at the 2D skeletal structure first, we can see the 6-membered ring comprised of carbons that I mentioned previously. And of course, it's missing some of the hydrogens, but trust me, they are there. We see both of the oxygens that are mentioned in the subscripts of C7H9 and 1O2. And these are going to be the 2 oxygens. Here's the single nitrogen with its tetrahedral electronic shape and its trigonal pyramid molecular shape. Although you can't see them, there is one lone pair right here. That is why it is going to be a trigonal pyramid, because 3 of the 4 electron fields are bonds and one of them is missing, or is just a single lone pair. Similarly, the oxygen right here is going to be tetrahedral as well as this one. There are 2 lone pairs that aren't here, but they are there, and that is why oxygen has a molecular shape that is linear. And then scrolling down, we can see another mol view diagram that I have created that just gives us a better picture of the 3D structure of the 4-methoxy-3-aminophenol, where we have our 6 carbons right here. The white balls are all going to be hydrogen, kind of circling the outside. We have our 2 oxygens right here, and then this is our nitrogen. And then I also threw in the 2D Lewis structure just to have another way to look at the compound, or the molecule, that was given to my group. And similar to the structure up here, the skeletal structure, with the Lewis structure, we can see everything that's missing. So we have our carbon with our hydrogens and our other hydrogens. Our carbons are labeled. And then this is the same right here with the nitrogen and the hydrogens. So yeah, thank you very much.